Alright, we're going to talk today about neutralization reactions. Remember that in order to be neutral, the pH must be 7. So, these neutralization reactions will bring your acid and base combination to a pH of 7. Neutralization reactions always look the same way. You'll have an acid plus a base turning into water and a salt. A salt is just an ionic compound, and so we'll look at some salts today so that you can see what a salt looks like. Remember that acids will start with one or more H's, and bases will end with one or more OH's. H at the beginning means it's an acid, OH at the end means it's a base, and you could have 1, 2, or 3 H's, 1, 2, or 3 OH's. Alright, let's get started with an example problem. Remember, if at any point in time these notes are going too fast, simply pause them, catch up, and then start playing them again. Alright, here we go. Remember, it always follows the sequence acid plus base turns into water plus a salt. So we'll always label our acid, base, water, salt. Our acid is HCl. I know this one is the acid because it starts with an H, and acids will start with one or more H's. This is my base, KOH. I know it's a base because bases will end with one or more OH's. So that's my base. I always know that one of the things is going to be water, but first I'm going to show you all three example problems. So my next acid and base are HNO3 plus CaOH2, and then after that H2SO4 plus FeOH3. So these are the three example problems we're going to work. Alright, now we know that water is always a product, but I'm going to show you why water is always a product. The way it works is that all of the H's from your acid and all of the OH's from your base combine to form your H2O. Okay, so there's your H2O. This one, it happens to work out. We have one H there, one H there, two H's, and one O. So it just makes one water molecule. In later examples, we'll have more H's or O's and have to worry about balancing them, but we won't worry about that right now. Alright, so that's my water. Now, how you get the salt. The salt is just a positive ion. Positive ions always come first. So K and Cl. The two things I have left over. I've already used my OH and I've already used my H to make water. Because K comes first in its compound, I will put K first in its new salt compound. And because Cl is second, because I have H first and Cl second, I will make Cl second in its compound. And KCl is my salt. So those two red ones combined to form my salt. Alright, we're going to go through it again a couple more times. I'm going to erase these lines here. Oops. And simultaneously reveal the answer. Okay, we know it's going to be water because there's always water. We know where the water comes from too. The water comes from all of the leading H's and all of the trailing OH's. This time I have two trailing OH's. That doesn't matter. What those are going to do is those are going to combine together to form my water. Okay, then what do I have left over? I have Ca and I have NO3. CaOH, the Ca comes first, so in my salt the Ca is going to come first. And in my acid, the NO3 comes second. It's an H first and then NO3. So my NO3 is going to be second in this. Now that NO3 is in parentheses for a couple reasons. It's in parentheses so that we can remember that it's a polyatomic ion, so it stays together. It's also going to get a little subscript out there, but we're not going to worry about that right now. Right now I just want you to get familiar with the concept of taking the leading H's and the trailing OH's away and making a water, and then taking your positive ion and your negative ion and putting them together over there. When I get back, we'll talk a little more about that next step. Okay, so last problem. Take all my leading H's, all my trailing OH's, and they're going to make a water. Then we have to look at what I have left over. What I have left over is Fe and SO4. Fe is the first thing in its compound, so Fe is going to be the first thing in our new compound over here. Oops, you could slightly see the 2 there. Remember, we're going to worry about that later. Right now, all I want you to do is be able to recognize that we're going to have Fe and SO4 in the next compound. So there's my Fe, and here's my SO4. SO4 will also get something else, but that is not important right now. Your work today will be making sure that you understand that a water will be created and determining what salt will be created. You'll have about 8 neutralization problems to work through. If you do that, those will be due at the end of class today. If you do those well, then I've got another video lined up that will illustrate the next step. So after you get it checked off that you did all 8 today, it'll be handed right back to you, and you will then attempt the next step, which is balancing these salts with the correct subscripts. Alright, that's all for today.